Problem 14. What is the value of the following expression? So in order to solve any summation, you always want to simplify it into as low of an argument as possible within the summation. So for the first summation, which is this one right here, we have the summation of k is equal to 1 all the way onto 20 of log base 5 of k times of 3 to the k squared. But notice something particular about log base 5 of k, of 3 raised to the k squared power. They're both raised to some sort of k power. So let's try to simplify this by change of base. So log base 5 of 3k squared over log base 5 of 5 raised to the k power must be the same as that log. But this can be rewritten as k squared times log base 5 of 3 all over k times log base 5 of 5, which is just 1. So notice that k and k can get cancelled by 1, so this becomes k times log base 5 of 3. So now we have simplified the first summation to be k times log base 5 of 3. Now let's consider the second one. The second one simply concerns with the same idea, except with different numbers as the base. So log base 9 to the k and 25 to the k, we can eliminate 1k by the similar logic of changing base to get log base 9 of 25. But notice how we can rewrite this even further. That's just log base 3 squared times 5 squared. And then applying the same formula again, we have log base 3 of 5. So log base 3 of 5 will go right here. Now that we have these simplified summations, we can evaluate it as such. But beforehand, let's try to utilize one summation formula, which is that the summation of a function times a constant must give the constant times the summation of the function. So we can rewrite the first one to be log base 5 of 3, because that's a constant, multiplied by the summation of k is equal to 1 all the way to 20 of k, multiplied by log base 3 of 5, because that's a constant, times the summation of k is equal to 1 all the way to 100 of 1. But with this, what can we say about the first summation, which is this one? That's simply an arithmetic sequence where it's 1, 2, 3 all the way until 20. Sum them up and we're done. So that's log base 5 of 3 times log base 3 of 5 times 1 plus 20 times 20 divided by 2 times what is the summation of this one? Well, that's just simply adding 1 100 times, so multiply by 100. So with this, we can simplify this even further by first combining these two logs. There's a rule that says log base a of b times log base b of a gives 1. Therefore, this becomes 1, and this quantity is easily solvable and will be done. So that's just equal to 21 times 20 times 50, which is equal to 21 times 1000, which is 2100, let's see, 1000, so 100. So 21,000 would be our final answer. So if you scroll up, 21,000 is answer choice E, and we are done.